talk a little bit about matrix notation. Okay, we have seen the notation R1, R2, R3 for a matrix with 3 rows and no specification of how many numbers are in each row. Well, I'm going to do one that has rows of length 3. Okay, so row 1 then is going to consist of 3 numbers. To give a general notation for those 3 numbers, I'm going to use A11, A12, A13 for row 1. The 1 in each of these subscripts, and often these subscripts are written with commas in case you get numbers bigger than 10, but this stands for 1, 1, not 11, 1, 2, not 12, 1, 3, not 13. And I'm not going to write the commas, it kind of gets in the way, although it's often important to include those commas, especially if your subscripts have numbers bigger than 10 or bigger. Okay, so row 1 is the A1s, A1, 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 but A1, 1, A1, 2, A1, 3. Row 2 is going to be A2s. So I'm going to maybe write just, there's an A2 here, an A2 here, an A2 here. I'm going to put the number of the column as the second subscript. It's the first column, second column, third column. Okay, then row 3 is going to be, well, again, A3, but A3 what? Now I got ahead of myself, but A3 1, A3 2, A3 3. So you have the number of the row, the number of the column. And this is a general way of writing out a 3 by 3 matrix. Okay, 3 rows, 3 columns. We could also write and I'm starting to put these columns in a column, and that's not what we want to do, is it? Okay, so let's do this correctly. I'll do a second matrix. And we'll use 3 columns for this matrix. Okay, so this matrix if we think of writing columns, okay, our first column will consist of 3 numbers. Okay, now I'm not going to use A for these numbers, I'm going to use B. And I'm going to distinguish the B's by using subscripts. The B in the first column is going to have second subscript as 1. Because remember, here we already established the convention that the second subscript refers to the column. So second subscript in the first column is always 1. Here's the second column, subscript is 2. Third column, subscript is 3. So we're going to have a 1 for the second subscript. And of course we're going to have to then number the different elements of the column with the number of the row. So we have B11, B21, B31, and then we'll have B second number in the subscript being 2 because we're in the second column, and then the first, second, and third elements live in the first, second, and third rows, notated like so. And then it's pretty clear that the third row is going to be B13, B23, B33. Now you might ask, why didn't I just copy down the subscripts from the A and just put B's in front of it? Could have done that, but I want to emphasize the roles of the rows and the columns and doubly emphasize what these subscripts are telling us. Okay, now, if I want to multiply these matrices, and let's give these matrices names, let's call this matrix A. And let's call this matrix B. A times B is, well, row 1, column 1, row 1, column 2, row 1, column 3, as we saw previously, and put the hats on the columns, and then row 2 times column 1, row 2 times column 2, row 3 times column 3, and then row 3, column 1, row 3, column 2, row 3, column 3. Notice that the subscripts match the subscripts that we see here. Okay? Now, what is row 1 times column 1? Let's go over here and write this out. Row 1, column 1 equals what? Well, A11 times B11, A12 times B21, A13 times B31. We match up the numbers in row 1 and column 1. Okay, so that's A11, B11 plus A12, B21 plus A13, B31. I just barely had room to get that. I hope that's legible. Okay, we notice that the middle two numbers, the numbers here and here, these numbers match up. Why is that? Well, the 1 in the second position in the subscript of A refers to the number of the column, and the 1 here on the B, which is the first of the two subscript numbers, refers to the number of the row. Or, if you wish, we have the first number in the row multiplied by the first number in the column. Second number in the row times the second number in the column. Third number in the row times third number in the column. We could write this in summation notation. Again, notation you might not be totally familiar with, especially at the beginning of the course. Hopefully you are. We're going to call this the sum from I equals 1 to 3 of what? Well, the other thing we can notice is that the remaining subscripts, the 1 here, and 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 the 1 here, those remaining subscripts are both 1. So we could write this as a sum of A1I times B I1. And when we write the product in terms of these symbols, we can write then the number that goes in the first row and first column as the sum of A1I, B, I1. And that's going to be the sum from I equals 1. Got ahead of myself. I equals 1 to n. Now, I'm not always going to write out the I equals 1 to n. It's going to be understood because in every case we're multiplying 3 numbers by 3 numbers. So we're going to have 3 indexes. I is going to be 1, then it's going to be 2, then it's going to be 3. Okay. Now we notice that the number that's fixed is the first subscript of A and the second subscript of B, because the first subscript tells you what row the number came from. So the first row here is going to have, first subscript is going to be 1. The second subscript tells you the number of the column. Well, when we did this one, the number of the column was 1. Okay, column of the B's, in doing the R1 times the C1 hat. Okay, well, then, just as another example, that we could do R1 C2 hat. Okay, equals, try to compress this writing a little bit. It's going to still be row 1, so it's A1, 1, multiplied though by the B number for the second column, okay, which is 1, 2. And then it's A1, 2 times B2, 2. And then it's A1, 3, which matches up with B, 3, 2. Again, we see that the first subscript of the A is always 1, and the second subscript of the B is always 2, because again, we're talking about the first row of the A matrix and the second column of the B matrix. The other subscript, well, it's going to go 1, 2, 3, 1, 2, 3, just as before. And the reason for that should be pretty clear, that we're matching up the first number in A with the first number in B. So first number in A with the second number in A with the second number in B, the third number in the A row with the third number in the B column. And we could write this as sum from I equals 1 to 3 of A 1I B I 2. Okay, well, I'm starting to encroach on the space I need for my matrix, and I'm probably going to have to write that thing a little bit downhill, so I don't want to do any more of this, but I'm going to generalize. So we have here then the sum of A1I BI2. Notice we're still in row 1 of our product matrix, so we're doing row 1 times column 2. And we're now in column 2 of the B matrix, because again, this number is in row 1, column 2. Well, then our third number in the column, if we accept the pattern that we see, okay, we're going to have an A1 because we're using the first row. We're going to have a B with second subscript 3 because we're now multiplying the first row by the third column, to get the number in the first row, third column. And then our I is going to go here and here, meaning again, the first of the numbers in the A row, first of the numbers in the B column, second number and third number, matching the two up. And again, all these sums go from I equals 1 to 3. And I haven't left myself enough room to write the whole thing out. And I'm not going to write everything out, but I'm going to write out the rest of it now. Okay, here we're going to have the row 2 times column 1. So it's going to be A2, B2, where the 2 is the first subscript of A, the 2 is the second subscript of B, and as before, the I's go in the middle. Again, indicating you're matching up the first number in the A row with the first number in the B column, and second number in the A row with the second number in the B column. If I is 3, it's third number in the A row, third number in the B column. Actually, I might go ahead and write this whole thing. But without making a mistake here, what I just said, yeah, these would be the first, second, third numbers in a B column, but this is B column 2, isn't it? Okay, and we're doing the second row of A with the first row of B. So let's correct that. Hopefully you noticed that and questioned it. This should be BI1. Okay, over here. Now, I wrote a 3 here, which again might have led to a little bit of confusion. And with apologies, this is row 2, column 3, obviously. All these are row 1, all these are row 2, all these are row 3. Okay, over here, then we're doing row 2, column 3. That's going to be row 2 for A, so we're going to have A2I, which is A21, then A22, A23, these 3 numbers. And then BI3, which means B13, B23, B33, matched up with A21, A22, A23. Then finally, the pattern's pretty well established. We're going to have A3I, BI1, sum of A 3I, BI2, and the sum of A3I, BI3. Okay, so by matrix notation, we refer to the numbering of the elements in the matrix with subscripts that indicate first the row, then the column of the entry. Using the matrix notation, we can write out in detail the rule for the product of 2 matrices. I'll also notice that if we do matrix B times matrix A, then the A's and B's switch, and unlike multiplying numbers, when you do this, you usually don't end up with the same product. In other words, A times B, the A matrix times the B matrix, is not equal to the B matrix times the A matrix. Now, for certain special matrices, that might be true, but in general, it's not going to be true. So that's kind of a big deal that I'll just kind of give a little heads up on at this point. We'll come back to it. Okay, so there's our IJ matrix notation. Apologies for the errors and or omissions. Hopefully that didn't create too much confusion.